Okay, so ours has a totally different tone than the last two. But we would still be saving lives. So, yeah.
Okay, so as I introduce this, this is mainly just a video over one of the big storms that happened. I know it was in Minnesota, but this is just some of the stuff that happened. We're going to talk about two different ways that we can make the roads better, safer. And so how many of you have been in a winter-related accident? So quite a few of you. I was actually in one with my parents over the blizzards of '08. We were just headed to the store and we just went into the ditch, so we were all fine. But it happens to a lot of us. Tom Patterson, who is one of the CNN reporters, he says that America's harsh winters cost the nation's economy billions of dollars each year in snow removal equipment, weather damage to streets and vehicles, extra days of school, and revenue loss to closed businesses. And so most of the money goes to buying the salt, buying the sand, buying in some of the main cities, they try and prevent it by putting the chemicals down, which also ruins the road, and they're paying millions of dollars because of that. And even the snow plows, when they go through, they're pushing the salt off, so the salt is just kind of pointless anyway.
Okay, so potholes. Has anyone had trouble with the alignment on their car or just different things happening?
Especially when it's your fault.
And that's due to the potholes. Over spring break, actually, the wheel hub on my brother's car came off while we were driving. That did not end well. But that was because of the potholes. They were just everywhere. And that will make you spend money on your car. As well as the black ice, if you slide or spin out, and it can be incredibly dangerous. So heating the roads, preventing that would help a lot.
Okay, so what these are going to do is they're going to take place of the roads that we are now. They're going to go mainly in high traffic areas, but they really can be used anywhere. And using these two different ways, you can also have less use of the salt and the sand that we use now.
And then the one that I'm going to talk about, which is called conductive concrete, will just go straight over field roads, no tearing or ripping things up. It can be used on any roadway for driving, walking, biking, what have you, safely, and no chance of danger. And then there's millions of dollars per year spent on the salt, the sand, the trucks, just maintenance. Alright, so conductive concrete has been tested in rural areas as well as in Lincoln, Nebraska. They've been testing it for 5 years. Like I said, it just goes over the old roads, has very low maintenance because it prevents the potholes and it prevents the other things that happen to a road, as well as being at least 2 times stronger than regular asphalt. Quick payoff because it costs way less to install and you won't have to worry about the upkeep. As I said, it was done in Lincoln, Nebraska. They tested it at the university. And what they do is they install these, they're kind of like blocks over the road, and then they'll fill it with wires and rods, and that put electricity through them and fill them with the concrete. We have a video next that explains it more in depth.
Roads. Ice can turn highways deadly.
salting are not making it disappear, but new technology is promising to. Chris Twan and engineers at the University of Nebraska-Lincoln are making a new kind of road, one that melts ice.
We threw snow on this about an hour ago. You can see the bottom of the snow has melted and there's no ice patches.
It's called conductive concrete. Heats up when plugged into a power outlet.
You can plug in a household socket, which is 110 volt AC power, and it will heat up the concrete.
What's inside makes it different from ordinary concrete.
These are the ingredients we use in the conductive concrete mix design. These are the steel fibers. They range from half an inch long to 1 inch long. This is the carbon powder.
It contains a mix of electrically conductive materials. It's poured into a concrete slab that's embedded with electrodes. When plugged in, they send electricity through the slab, generating heat.
Once we cast the conductive concrete, we stick this thermocouple wire to the center of the test lab to measure the temperature of the test lab.
Today, they're testing the heating performance of different conductive mixes.
The freezer is at a 25-degree temperature, and the test lab is hooked up to a 110 volt AC power. And we're gonna dump some snow on the test lab.
They think they found a mix that can de-ice roads.
You can tell it just started melting.
We're testing it here in Lincoln, Nebraska. This bridge is made of 52 conductive concrete slabs. Each has its own electrodes connected to a power source.
This is the control room. And these are the relays, the power hookup. And here's the controller. Basically, it controls the power on and off functions.
The bridge turns on when the temperature turns down.
If the temperature of a slab is higher than 55 degrees, the power shuts off automatically. And if the temperature drops below 35 degrees, the power will kick back on.
It can also be turned on remotely to catch big snowstorms.
Basically, these two are the control buttons. You dial it, you turn it on, and let the bridge do its thing. And then when you think the snowstorm is over, just hit the stop button and turn the power off.
It takes 6 to 8 hours to warm to a toasty temperature that prevents ice.
When the panels are powered, you can put both hands on the conductive concrete without getting shocked. And the highest temperature it will run is only 50 degrees Fahrenheit, and it won't burn your fingers or anything. So it's absolutely safe.
The electric power running through this bridge can run 23 air dryers. The team's been eagerly monitoring its performance in rough weather.
This year we got 3 snowstorms. 2 of them had more than a foot, and conductive concrete has been working there as well. When the snowflakes touch the deck, it melts instantly.
They're also keeping tabs on the bridge's electricity bill.
They cost about $200 a snowstorm. So compared to the other de-icing technologies, it may have the potential to become the most cost-effective de-icing technology.
It's not cheap to build these roads, but once the conductive concrete is poured, it needs little maintenance. Lab tests show it's almost twice as strong as regular concrete, and its overall benefit is priceless. 10 to 15% of all roadway accidents are related to bad weather.
Using this technology, you would avoid all the icy bridges that would potentially save lives. The application is not just limited to the highway bridge applications. You can implement this technology for the sidewalks and driveways because a lot of people during winter they slip and fall and cause injuries.
They'll spend a couple more winters gathering data, and if it works, conductive concrete could not only provide safe travel, it may relieve us from the backbreaking shovel.
Of course, it may be some time until all roads, sidewalks.
Oh, sorry. Okay, so like I said, it's safe stronger, very low maintenance, and it's easily controlled by the button that he demonstrated. So like I said, it's been tested since 2005 in Nebraska. And he said it only takes 10 volts of AC power, so you could run it for as much or as little as you'd run your AC. So it'd make it effective for driveways or even like the sidewalk outside of your house. Like they said, it gets to 35 degrees, it'll turn on so that it's ready if anything happens. $200 a storm, which compared to $2,000, $3,000 for the salt and the sand is a lot less. And then,
Okay, so the other way that we go is with water coils. This technology is actually used a lot, especially with heated driveways. If your driveway is at a steep slope, a lot of people will go the route of the water coils so they don't have to shovel and you don't have to try and get up it when it starts getting icy and stuff like that. But what it is they first have to put the coils in the pavement. So yes, the roads will have to be torn up, but the water that runs through it heats up during the summertime, so you're not using any of the power, and it's all actually stored until it's needed in the wintertime. And then when you're not using the heated water, it can actually go and power your home. A lot of them are solar paneled, and it's really good for the environment. These would be most likely in high traffic areas. And if you do this, you're gonna have no more potholes, and I really would like that here in Cedar Falls. But here's a video that kind of goes more into it's glass pavement, so they kind of go into that after this.
December of 2007, a ton of liquid asphalt was $175. We're getting quotes at over $1,000 a ton now. Asphalt has gone up so much because of petroleum based. I don't believe we're going to have the ability to
You
build
threw out a lot of big words too, by the way.
What we're proposing is a road that pays for itself over its lifespan. Not only pay for itself, but provide a whole slew of new features. Welcome to Solar Roadways. There's 25,000 square miles of road surface with parking lots and driveways in the lower 48 states. If we cover that with solar panels with a 15% efficiency, we produce 3 times more electricity than this country uses on an annual basis. And that's almost enough to power the entire world. Roads are collecting heat anyway, this can collect the power and stores it. Your whole road is an electric grid that delivers the power right to your front door along with cable TV, high-speed internet access, your telephone, everything right there. The technology behind it has already been done today. I'm just taking a lot of different technologies, making something new out of it. The one thing that hasn't been done is driving on glass. It's got to have the same traction as asphalt, has to be strong enough to support a fully loaded semi-truck, locking them up at 80 miles an hour, shatterproof, fireproof, transparent enough to allow the sunlight through, but not to allow the glare back into the driver's eyes. All these specs.
The idea of making a road out of glass is really out of the box thinking, because most people, when you mention the word glass, all they can think about is its fragility and ability to fracture. In fact, glass can have as high a strength as steel. We know how to manufacture glass. We know what photovoltaics are. We know what we have to do to protect glass from damage. We know what it takes to lower manufacturing costs. The research that's really needed has more to do with adapting glass for this particular application.
A solicitation came out from the U.S. Department of Transportation for an intelligent pavement that could generate power and pay for itself. And so we applied for it. That gave us the funds to actually build the prototype. We purchased parts to build a 12-foot by 12-foot full-size solar road panel. And our solar road panel has a 32 by 32 array of individual electronic modules. Each of these have LEDs, 3 white and 3 yellow. We milled some trace underneath for the cables. So our cables are coming in and they feed the electronics modules. We're sending commands to the microprocessor wirelessly. The microprocessor determines which of the LEDs are lit up. And then it's spelled words this way. There's a total of 6,072 LEDs in the prototype. So we can spell just about anything we want in there. In addition, we built a 3-foot by 3-foot panel with a frame around it. We call this our crosswalk panel. There are load cells in here, and it's a weight machine basically. If you're driving at night, you're daydreaming or something, and somebody steps off in dark clothing onto a crosswalk in front of you, that crosswalk starts to flash, the road in front of you starts to flash, it gets your attention and tells you to slow down. What we've learned is your LEDs are recessed into the road. If you stand pretty far off from it, you can't see those LEDs anymore. So what we've discovered is we can actually put it inside the glass layer on top. What we'll do later is fill the interior with a cold turning laminate.
And in that way, they're sandwiched in a hermetically sealed environment so that moisture won't get at them.
We want to pull the garbage out of landfills and out of the ocean. We can take that trash, we turn it into little pellets, we mix that with organic material to make the internal support structure for our solar panels. There are engineering degrees out there they didn't have when I went to the environment.
So what we're trying to do is just mainly keep the roads above freezing temps so that the snow when it comes down it doesn't freeze right away. That it is not going to cause the black ice situations and cause accidents in London. So just the comparison between the two, they both have a quick payoff. If we use both of them combined, it'll be about 6 years to pay off the money. And they both have the different benefits, and we've been over both of them. They do take time to install, and we are thinking of doing coils for the high traffic areas, and then the connective cement for the separate areas.
So what we have already is $3,000. We estimated it's going to take about $500,000 to install 50 miles of roadway. So we need $200,000 more with 10% of whatever we get back. Regular concrete is $1.3 to $1.4 billion to install 3 miles of it. So 50 miles for half of that is a large difference. The conductive concrete is $237,000 to put in place and maintain for 3 years. It'll pay off in just the first couple years because of the little to no repair. It does not take very much for electricity, and there's little to no salts and chemicals. The water coils is $125,000 to construct and $1,000 a year to maintain, and it yields enough annual energy to power 55 homes for a month.